Hello, everyone. Good morning. Good morning. Um, I hope everybody is feeling good about being close to the finish of the class. Um, if anyone has forgotten, just a reminder that your final exam can replace any of your other three exams also. So if there's any of your three exams that you don't like, that you're, confident or feel good that you could do better on the final, I'll replace that grade with whatever you get on the final. And that can actually make quite a bit of difference. I've had people that have gotten, D's on a test and then get a B on the final. And between getting the B on the final and then going back and replacing the D, it like brings their grade up by 10% or something like that. I mean, it doesn't happen in every case, but it definitely can help your grade a lot especially if you had one bad test. Um, if anybody wants me to figure out like what do I need on the test to get this certain grade, I can do that for you. It's kind of complicated because you have to throw out, I mean, not complicated, but it's a little bit tricky because you have to throw out one of your other grades um, and recalculate where you would be with that grade thrown out and then what it would be with the final grade put in as a replacement. So it's not quite as easy as it is if I didn't offer the replacement of a grade. So, but if anybody's really wanting to know, like, what do I need to get a B? What do I need to get a C? What do I need to get to pass? Just shoot me a quick email and I'll help you out. So, um, and also if anybody's missed a test, hopefully you guys know that if you missed a test, that one will be replaced by the final. Is everybody good with all that? All right. Um, and I finished the final yesterday, so it is up and ready to go whenever you are. I know you're super excited to take that final. So, but it is up and ready to go. I'm fairly happy with it. And the review that I put in D2L is what we're going to work on today. So if you haven't looked at it, this will be a chance to see it. If you have looked at it, you could see, if there's anything that you had questions on. I mean, ideally you would have done it before we went over it together, but I don't want to wait until Wednesday to go over it. So I'm going to go ahead and go over it today. So, all right, let me see if I can get my screen shared here. Okay, so this is the review. This is the same one that's in D2L. So if you don't have it, haven't looked at it or printed it off or anything, you can go to D2L. There's the review and there's a key. But I think this will help you focus a little bit on like what you might see on the final. Like for instance, I'm not going to ask you to do standard deviation in chapter 3. You don't have to worry about going back and figuring out how to do that. You might be asked about standard deviation, but I'm not going to have you calculate it. So okay, let's see if I can get this so that we can write on it. All right. So let's just kind of go over these. I just thought we'd go over them one by one unless somebody has something else you want to focus on. I know you've been probably finishing up your corrections and taking your test and all of that. So for chapter 1, what do you guys think? What are variables with values that are determined by chance called? And the key here is by chance.
Random variables, right?
Random. Yep. And when you're doing this test, just in general, remember that it doesn't mean I'm specifically going to ask a question exactly like that. These are kind of the concepts you need to look over. So you need to make sure that you know what random means, that you know what variables are. So if you look at this and you're like, wait, I can't remember what a variable is, go review that from chapter 1. And a variable is just anything that you're studying. So I think one of the things we used way back when was like hair color is a variable. Some people have blonde, some people have gray, some people have brown, some people have black. So your hair is a variable. Hair color is a variable. your height is a variable. The number of cars that pass through a checkpoint on the tollway is a variable. So anything that you can gather data on and that can change is a variable in statistics. It's not like the X and Y and Z in algebra. I mean, they're similar. They're both called variables because they can change, but we treat them a little bit different in statistics. So, okay, so what about questioning every 14th customer? So in this problem, the key here is that we're doing every 14th. Do you guys remember which type of
systematic?
That's systematic. Yep. So when you do this very systematic method, good, of every 14th or every 20th or whatever. But again, on this, remember that I could ask anything about any of these types of sampling. So random sampling, stratified sampling, cluster sampling. Random sampling, remember, is always best if you can. You know, so if I ask you what's the best kind of sampling, random sampling. If I said, you know, is this method the best method you could use? The answer would be no, because this is systematic, not random. So that idea of, you know, understanding what all of these are is important. Do you guys remember what the cluster sampling was?
Is that whenever you take?
Go ahead.
Oh, I'm so sorry. It's whenever you like this many freshmen, this many sophomores, would it be like that?
That's stratified.
Okay.
So this is when you break into layers. That's where the stratified comes into. So you might have, like you said, you might have like freshmen and sophomores, and then you might have male and female freshmen, male and female sophomores, and then the male and females, you might have, you know, STEM, non-STEM. And so if you do that, you end up with, what is that, let's see, 1, 2, 3, 4, 5, 6. So you'd end up with like 8 different groups. But the problem with this is a lot of times people will make like the 8 groups all the same size, which doesn't represent the population very well. The population may not have the equal number of freshman male STEM as they do freshman male non-STEM, and so on. And so, but that's stratified. So what's the cluster?
Is cluster sampling is like when you go to a restaurant and then hand you some flyers and you, like, they're asking, what do you think of these things? And then the people will just kind of fill it up or something.
So you could kind of do that. That would probably be considered more of a convenience sample, where you do something that's, you know, in public, that's really easy. It could be considered cluster. The idea with a cluster is that it's an intact group. So something that's clustered together. So like if you like a class, or you know, all the people in one neighborhood, you know, if you asked one neighborhood their opinion about, or found out something about them, and then tried to say that was all of the Houston Metro or something like that, but you only asked one neighborhood, that would be a cluster. So think of cluster as like a group that's intact. So what do you guys think of that? You guys remembering those okay? Kinda. I mean, I'll definitely probably ask something about sampling. So here, let me put over here on the side. Okay, so for sampling, and actually I have the book right here. Let me read the definitions of the different types of sampling if I can find it. So for random, everybody's okay with random, right? Like random is random. Like you roll a die, pick names out of a hat, something where you just absolutely don't mess with it at all. What it says for systematic sampling is it's obtained by selecting every, they use the variable k, kth member of the population, where k is a counting number. So random is, you know, draw a name out of a hat, etc. Systematic is every kth item. And then what it says for stratified, The actual definition out of the book says it is a sample obtained by dividing the population into subgroups or strata according to some characteristic relevant to the study. So this is where you have, again, this is like layers. So you have subgroups. And then what it says for cluster is obtained by dividing the population into sections or clusters and then selecting one or more cluster at random and using all the members in that cluster. So all from one intact group. So like a class or a neighborhood or something like that. And those are really the only, I'm not really going to ask anything. There's other sampling methods, but they just mentioned them very briefly in the book. I'm not going to ask any of the others. It'll be one of those 4. So does anybody have any questions on that one?
Thank you.
You're welcome. And if you guys want to go back and look at them, these are out of section 1.3. So if you want to go back and look at them, or maybe even do some practice problems or something, you could go back and do that and see how you're doing on finding those. So of course this is all chapter 1. The final has it by chapters, just like the review does, and just like the other tests have been. So it says chapter 1, chapter 2, chapter 3. So okay, let's clear this out. All right, what about this third one? A television station reports 89% of Houstonians think the Astros are the best baseball team after surveying random local people with the question, being a Houstonian, would you agree that the Astros are the best baseball team? So what do you guys think that is? Is that suspect samples, detached statistics?
That's faulty survey question.
Yep, you're definitely confident that that's a faulty survey question?
Absolutely.
You are correct. Because you lead them into an answer. Being a Houstonian, so you remind the people that, hey, you live in Houston. Would you agree? Most people want to, if you say, do you agree? People are more likely to say yes. They may even say yes and then go, wait, no, I didn't mean that. You know, it's kind of like when somebody says, have a good day, and you say, you too. You know, everybody wants to be, not everybody, but most people want to be agreeable. And so when you ask somebody, would you agree? They want to say, sure. And to defy that is more against your nature. And so this is leading people into saying yes. That's a faulty survey question. So what's the difference between that and a suspect sample? Because people get these confused.
In a suspect sample, there would be a poor sample group, right?
Yes. So this is when you have a bad sample group. I won't say bad, but a non-representative sample. So here it says surveying random local people. So it's not the sample that's bad, it's the question that's bad, because they were surveying random local people. So it's not suspect samples, it's not the group of people that they're picking from, it's what they're asking them that's a problem. Does that make sense? The difference between those, people get those mixed up. A suspect sample would be, the example we used was like if you ask people who are coming out of a movie theater if they like science fiction. Well, that's not a representative sample of the population. So you're not asking them necessarily a bad question, you're just asking the wrong group. Ambiguous averages, that's when, most of the time, ambiguous averages is when they use mode, median, or mid-range with no explanation. Because the most common, typically, you should use the mean most of the time. And so if they use the mode, the median, or the mid-range without explaining why, or they switch back and forth, and you know, like one group they'll list the mean and then they try to compare to another group where they list the median. Like, why did you say in this group it was the mean, in that group it was the median? Why are you switching? That's ambiguous averages. Do you guys remember what detached statistics are?
Not really.
It's used a lot, actually. And think of that word detached. Detached means not attached, right? So this is if you say, for instance, that it has 30% less sugar. But you don't say less sugar than what. So when you're not giving the original value, we have no idea what you mean. Do you mean 30% less sugar than the competitor? 30% less sugar than their former product? 30% less sugar than what most people have on their cereal or whatever they're talking about? But when you don't attach that to anything, that's a detached statistic. They actually do it a lot in advertising. If you watch for it in advertising, you'll see them do it a lot. They'll say, you know, it's better, or it's lower, or it's a lot of times it's this percentage, 30% less, 20% better. Better than what? They're just hoping that people will assume that that means something great, and they don't explain what it is. So it's kind of playing on that idea that people won't question it. So I found if you guys want to see a wonderfully bad, I should say, graph, you should see the graph that the state of Georgia put out about why they're ready to open. They list the counties, like the rates of COVID by county and by date, but it's like a multi-bar graph, and each group of bar graphs, they change the order of the counties, and then the dates on the x-axis aren't in order. So they go from the highest to the lowest, but they don't put them in the order, like in time order. I about had a heart attack. Okay, so anyway, but people will just glance at it and think, oh, look, everything's, you know, it's going down, because they see the bar graph, the bar's getting lower. They won't look at what does the x-axis have on it. And so then it manipulates people. All right, so a recent statistics exam yielded these scores. We're supposed to complete the frequency table and then draw a frequency polygon. So remember the difference, what's a frequency polygon versus an ogive versus a histogram?
Doesn't the frequency polygon have the lines?
Yes, this is a line graph.
And isn't it attached on both ends?
Yep.
It has an yeah.
So it's anchored
Yes, anchored.
on both sides. And then the ogive looks a lot like the frequency polygon, but what does an ogive do?
Well, I know it doesn't it doesn't connect to the ends, right?
It only does at the start.
Oh.
So anchored at start.
And can it only go up?
Yep, it can only go up because it's cumulative. So because it's cumulative, it adds that group plus all the prior groups, and so it can only increase or stay flat. If a group has 0 in it, it would stay flat, but it can't go down. So a frequency polygon is typically going to look, you know, something like this, you know, whereas an ogive is going to look like this. It's going to go up, 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 up. What about a histogram?
That's like a bar graph, right? But
Yeah.
it just uses the classes.
Yep. So it's a bar graph with the boundaries along the bottom. So boundaries on the x-axis, and then you have bars for the classes. Here, we'll add that. So it's a bar graph of the it's actually, well, it's kind of a bar graph of the classes or the boundary groups. So in this one, it's asking for a frequency polygon, and so that's going to be the line graph. And in order to do that, we have to find the midpoints, because the midpoints is where we put that one dot for that whole class. So what's the midpoint of 60 to 69? basically halfway between 0 and 9 is what we're looking for.
64.5, right?
You got it.
And then you add 10 for all of them.
Yep. So the average of 60 plus 69 divided by 2 would be 64.5. And then this would be, like you said, now we know they go up by 10. And so this would have to be 74.5, 84.5, 94.5. By the way, if anybody finds anything wrong on the key, let me know. Okay, so on the tally then, we're just going to go through these and start to mark them off. So 80, there's one there, mark that one off. 99, 97, 67, 93, 91, 76, 86, 79, 71, 92, and 78. And so you just, use those little marks to keep track of everything and then total up how many there were. So there was 1 in this group, 4 in this group, 2 in that group, and 5 in that group. So this isn't going to be on the test itself, but you might have to tally something up. That's what you would, do that on your paper so that you could make sure the frequencies are right or fill in the frequencies, whatever the question might ask. So now, where would we put the 1 value at? Did I put it at 60 or at 69?
64.5.
Yeah, that's why we do the midpoints, because that's where that 1 point is supposed to go, right? So for this class of 60 to 69, on a frequency polygon, we'd put 1 point at 64.5. And then for the next one, we'd put 4 at 74.5. And then for the next one, we'd put 2. Just make sure you put it right above the midpoint. I would say on the first test, the biggest mistake people made on this was they either did a histogram. I think the first test we took, I asked for a frequency polygon, and there was a couple people that did a histogram by mistake. And then there were some people who did this, but they had it off. Like they had this dot over here instead of right above the 64. So make sure you put that dot right above the midpoint. Okay, so we'll connect these, and then what else do we have to do? You guys just said it a minute ago.
Anchor it.
Anchor it. So there has to be an anchor back at what would be 1 class prior and then 1 class after. So back 10 and up 10 and anchor it down to show there was nothing in this class, there was nothing in this class. So that's what that one would look like. What about if we did a, let's do a histogram too. So if we were doing a histogram, what would the bottom be labeled with if we were doing a histogram?
The boundary.
Yeah.
The boundaries, which is the correct answer, not class limits. So I don't want to go 60, 70, right? Because then when you look at this, you don't know if this bar includes the 70 or if the next bar includes the 70. So we haven't done this for a bit. What are the boundaries? What would the first boundary be for this
Is
class?
it the 59.5?
Perfect. Good job, guys. Okay, so 59.5. And then the next one would be 69.5, right? And then that way we know when we look at this bar, which is going to come to 1, because that would represent that first group here, we know that this is 60 to 69. It doesn't include 70, and it wouldn't include 59 if there were a 59 in there. Okay, and then we just keep doing that. So the next one would be 69.5 to 79.5. That would be 4. And so on. And then we know that in here is only 70 to 79. It would not include 69. It would not include 80. So we know specifically that this bar only goes from 70 to 79 because we do those boundary values. If we put an 80 here, we don't know if we would put an 80 in this bar or that bar. Or if, let's use this one, like if this was 70 instead of 69.5, we wouldn't know if the 70s went in this bar or this bar. So we want to put something that's not an actual value in one of them. So we want to use those boundaries. And then let's do a, oh, I'd have to really, actually, let's just use this one. So if this was an ogive, we'll use this one because this will be the easiest one to go off of. If we were to make an ogive, I am going to have to redo my numbers on the side though. Where's the eraser at? Oh, it's right there. Because what's this have to total, what does this have to go up to on the side if we're going to do an ogive?
99.
Well, that's along the bottom here.
Oh,
Is it 5?
So this has to go up to 99.5. Yeah, what about here on the y-axis if it was an ogive? What would it have to go up by? Or what would it have to go up to? What would be the biggest thing?
would it be 12?
I heard 5, but 12 is correct because I want I have to get this total, right? And ogive is going to total it up. So 5, 6, 7, 8, 9, 10, 11, 12. I've got to get up to 12. So let's go by 2s instead of 1s. 2, 4, 6, 8, 12. And so at 59.5, I would have how much? Where would I put that at? How much of the data is 59.5 or less?
0.
0. So there's your anchor on the left. How much is 69.5 or less? Only 1, right? That's that one. And then how much is 79.5 or less?
4.
Add the 1 before it too, so it's actually 5. So the 4 plus the 1. And then the 89.5 would be
7.
7. And then 99.5 or less would be all the way up at 12. So your graph looks like this. It only goes up and it totals things as it goes.
Is that called the cumulative frequency?
Yeah, they used to always call this a cumulative frequency polygon. And then at some point, I think somebody said, wait, you can't call that a polygon because it doesn't attach on the end. Like this one makes a, you know, like an enclosed shape with the x-axis. And so then they came up with this other name. I'd never heard it called an ogive until probably about, I don't know, 10 years ago. When I was in college, we just called it an ogive, which was just, you know, when I was in college, it was just a couple days ago. But anyway, back in the 80s when I was in college, we just called it a frequency polygon, or a cumulative frequency polygon. So you'll still see that used sometimes. All right, so remember on the final, you're not gonna have to really, like, I don't have anything where you have to, you know, draw this, take a picture of it and upload it. Like you're not gonna have to do this by hand necessarily, but you might have to pick out errors on a graph like I did on some of the, I think I did that on some of your, no, that was the other class because you guys didn't have this test online, you had it in person. But anyway, one of the things I've done is I've given, you know, here's some examples of some graphs, which one's right, things like that. So just remember if it's an ogive, it should be accumulating, it should be anchored on the left. If it's a histogram, it should be a bar graph and all of that. So maybe go back and practice a couple or look at a few if you feel like you're not remembering that very well. Does anybody have any questions about 4 before we go on to 5? Okay, so let's clear this out. And so this one, of course, is a what?
Histogram.
That's a histogram, and it's already done for you. And this one actually isn't done very well. This should actually probably be 34.5, 45.30 or 44.5. Like this should be have the midpoints, and it probably doesn't. But this one is just asking how many values. So it doesn't really matter that the x-axis is labeled poorly. It wants to know how many values are in here. So I'll get answers like this, 6, or I'll get 8. Those are both wrong. You know, they'll
Is it
say 1,
28?
2, 3, 4, 5, 6 bars, or 8 because that's the tallest. 28's right. Now, how do you get that?
You add each of the amount that's in them. Like that's 3 and 5.
Okay, and 8.
6, 4, and 2.
Yep. So you add those all up. 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. And that totals to 28. So this bar contains 3 values. This bar contains 5 values. So if you were to write these all out, you would have, 28 data values. There'd be 28 of them. So you'd have from the first value, which could be anywhere from 35 to 45, all the way up to the 25th or 28th value, which would be somewhere between 85 and 95. So you would if you listed all the values out of this, if you had them all listed out, there'd be 28 of them. You guys good with that?
Yeah.
You wouldn't believe how many people, I mean, this one really throws people. 6 is the most common answer I get. I say how many values, and they'll say 6, but there's 6 classes. That's not what it's asking at all. It's asking how many values are in there. How many values does that hold? Okay. So this question, let's just kind of refresh here. So this question asked about a frequency polygon. This question asked about something about a histogram. And then this, even though, it's a different kind of problem, this one's what kind of graph?
Ogive.
Ogive. So, if you look at this review, I've asked about each type, just a little bit different question. So I could ask, this question, what does this point represent, and do a histogram, or what does this bar represent, and do a histogram. Or I could say, what does this point represent, and it be a frequency polygon. Like I could ask these same questions about a different kind of graph. So don't get too stuck on, oh, if she asks that question, it's an ogive. I could ask that question about any of the 3 kind of graphs. And I'll probably ask something about one of each of them. So this one takes a little bit of time because you have to do a little bit more construction. This one, you have to add them up. This one's a little bit more, descriptive. So the point 59.6, so that's this point right here. What does that mean? And at that point, I would say, okay, well, I need to look at the axes. What is this? Well, this is the age. We're talking about golfers. And this over here, cumulative. So this is an ogive, right? Because they're giving us the cumulative. They're also giving us relative. What does relative mean? And if you look at these numbers, it might help.
Hey Google, what's the weather outside?
What's that? I didn't hear you.
Is it a percent?
There you go. It's a percent or a decimal. It's how much out of the whole.
So is it saying that 60% of the golfers are?
There you go. That 0.6 means 60%. You're right. So 60% of the golfers, or 0.6 of the golfers, either one would be fine.
Or at least 50, or at least like 50.
Or 59?
Okay, 59 years old.
Or younger.
Or younger. There you go. That's the key. There you have to be, they're 59 or younger. You have, it looks like about 10% that are 19. And then they go up to, it looks like about 30%. So that means there must have been an additional 20% by the time you get to 39. And then another 30% at 59. So there was 10, 20, and 30% at each of those levels, which totaled 60% of the golfers by the time you got to 59. but that includes the 39 and unders and the 19 and unders. Does that make sense? The key here is to remember that it has to have the or younger in it when you're talking about a cumulative. And that relative means percentage. If this was, I mean, this could be, you know, not relative. It could be just actual numbers. And here, let's do this in red. So let's say it wasn't relative. And let's say this was, I don't know, 5, 10, 15, 20, 25, and 30. And I asked, what does 5915 mean? Then you would say that means that.
Would it be like there's 15 people or golfers that are 59 or younger?
Yep. So 15 of the golfers are 59 or younger. It's still cumulative, so you still want to do the or younger. It's just that we have an actual number here instead of a percentage. So here it's 60% of the golfers, and we don't know what the total was. Here we know the total was, I think it's actually 25 because that other one is above. So here we know there was 25 total. Here we know, we don't know that. We only know that it was 60% of them. We don't know what the total was. So the difference between the relative and the actual is just whether or not they give you an actual number or if they give you a percentage. So what do you guys think? You guys have any questions about that one? Okay. So again, just kind of be familiar with these. It's probably going to be more of a pick out the correct graph or pick out the correct explanation. You know, there's pretty darn hard on the computer to have you write out what it means. So much more likely that there'll be like 4 selections and you have to pick out which of the descriptions is correct. You know, I might say, you know, say it was this one, I might say 15 of the golfers are 59, leave out the younger part. Or I might say, you know, 59 of the golfers are 15 years old. You know, just mix it up somehow so it's not quite right, and you have to pick out which one is correct. Most of the final is multiple choice, but I mean, not every single problem, but most of it. All right, anybody have any questions on chapter 2 before we go on? Okay. So biggest thing with chapter 2, know what a histogram, frequency polygon, and an ogive are. So, okay, the old familiar mean, median, and mode. Hopefully this is one that you guys can do and be like, I know I got that one right. So what do we do for mean?
Add them all together and then divide by the total amount of them.
Okay, so sum them up and divide by the n, by how many there are. Okay, so what does this sum up to be?
14.9.
What's the sum before you divide?
Oh, 119.
So it sums up to 119 if you add them all up. And then there's 8 of them. And you said it was what, Vinay?
14.9. We wouldn't round up to 15, would we?
No, you're supposed to go one spot past the original data. So 14.9 is perfect. Okay. What about the median?
You put them in order from greatest to least and then find the one in the middle.
Yeah, you have to go smallest to greatest. So 2, 8, 15, 16, 16. 20, 20, 22. Let me know if I did anything wrong. Does that look like all of them? 1, 2, 3, 4, 5, 6, 7, 8. Yeah. Okay, so where's the median at in here?
16.
Yeah, between the 16s, right? It doesn't technically fall on a 16, but it falls between 2 16s, which means the average is what? Or the median is what?
Is it 16 divided by 2?
Well, it'd be 16 plus
It's just
16 divided by 2, which is 16. It'd be the
16.
average of 16 and 16. So like, let's say you were doing this and it came out, I don't know, on one side you got a 20 and on the other side you got a 27. What would you get for the median?
23.5.
Yeah. You do 20 plus 27 divided by 2 and get the average. So if it falls between two values, you average them. But if the two values are the same, you know, the average of two of the same numbers is that number in this case. Okay, what about the median? Or, I'm sorry, the mode. Just did the median.
That's the one that shows up most often, but it's looks like 16 and 20 show up.
Okay, so 16 and 20 both show up twice. So
Yeah.
we say 16 and 20, right? What if it was 16, 16, 16? Well, actually, let's do it the other way around. What if it was 16, 16, 20, 20, 20, 22? What would the mode be?
We would go with 20 because there's the most amount of 20s, right?
Right. Now, what I'll have sometimes is people will still say 20 and 16 because they say, oh, well, they both occur more than once. And so they must both be the modes. But that's not the case. It's whatever occurs the most overall. So the fact that there were 3 20s, you would just say 20. And what if nothing occurs? Like, what if everything happens twice or everything happens once?
Would there be no mode?
Yep. Don't say 0. It would be no mode.
Oh.
So no mode
Oh,
or
okay, gotcha.
none. Because a 0 mode would mean you actually had like a 0 value and that was in the middle. Or that was the most often. So. And you're like, when would that happen? And actually, it happens quite a bit. Like if you look at the incomes, the most common income is going to be 0 because everybody that doesn't have an income is going to be 0, whereas all the other people are going to be, you know, scattered about. You know, one person might make, you know, 50,728 and another person makes, you know, 50,729. Well, those are different values. So the most common value when you go and look at incomes is probably going to be 0, but that's not very representative of the income. So that's why when they start using median and mode as descriptors, that's why we call them that ambiguous averages. Like, why would you not just use the mean? Why are you not using the mean? And there should be a reason for it. Okay.
What can you tell me what the mid-range of that value is?
Sure. I'm not going to ask it, but the
Okay.
mid-range is just from the bottom to the top, so 20 to 22, and it would be like what's right in the middle of those. So it's saying like the bottom is 2, and then it goes all the way up to 22. What would be right in the middle of that?
So
what
is
that?
it really the same as the median? Or not the.
No,
Okay.
it's not the same. They both measure middle, but they don't get you the same value. So like in this case, 2 to 22, the mid-range would be 12, but the median was 16.
Okay. All right.
So it's right in the middle of the lowest and highest value. What's the range of these? I didn't ask that here, but if I did, what's the range?
Is it like 22 minus 2?
Got it.
Okay.
So it's 22 minus 2 is the range, which is 20. And then the mid-range is right between them. And same thing, mid-range is pretty like they don't typically use mid-range. So if you see them using mid-range, you might say, well, why are you using mid-range instead of median? Median's kind of a more common thing to use. So that might be when you kind of question in the study, why are you doing mid-range instead of, are you trying to make it look better, look worse? Okay, so let's look at this next one. And here it asks you to find the mean and the modal class. Let's do modal class because that's easy. What's the modal class?
38 to 46.
You got it. The one that has the most, right? So 38 to 46. Now, the mean is a little bit more difficult computation. You guys remember how to do that?
You find the midpoints,
You do.
and then you multiply by the frequency.
Yep. And the reason for that is this is grouped up. We don't know what the original data was. So we're going to assume, we know there was 5 somewhere between 20 and 28, but we don't know if it was a 20 or a 21 or a 22 or a 23 or 24 or 25 or 26 or 27 or 28. We don't know which one it was. So we're like, well, if we don't know what it was, let's assume they were all 24s. And then we're hoping that, you know, some of them are high, some of them are low, but it'll average out okay. So it's the best we can do when the data is grouped up and we don't have the original data. So what's that? 120, I think. Okay. What's the midpoint for 29 to 37?
33?
33. Yeah, this is a weird.
And how do you calculate that again? Is it 37
Plus 29.
minus 29?
Plus 29, because you're trying to find the average.
37 plus 29, then divided by 2?
Yep.
Okay. So add.
Or the other thing you can think of it, it's just right in the middle. So if you think, you know, 29, 30, 31, 32, 33, 34, 35, 37, 38, or 37, that's 7 values. So I have to go to like the 4th value to find the middle of it. Different people think of it different ways, but, you know, like if you think of this as, you know, it could be any of these values. What's right in the middle of those? Well, right in the middle of those is 33. There's 4 above and 4 below. So the midpoint's 33. So if you get a little confused, you can kind of lay them out and look at them that way. But the biggest thing is it's the average. You can do it that way most of the time. Okay, what about this one? We're going up by 9s, it looks like. So this one must be 42. And this one would be
51.
51.
Those are kind of strange class limits. I can tell you if I do that on the test, it won't be quite, it'll be a little nicer numbers. Okay, so 33 times 11, what's that come out to be?
363.
And then 42 times 12.
504.
And then 51 times 2 would be 102.
2. Yeah.
Okay, so now what, guys? What's the next process? I'm going to get rid of this because it's kind
Would
of
you add those up and then divide? Or no?
Yes. Okay, so this is the modal class. Okay, so you'd add these up. 7, 8, 9, 8, 3, 4, 9, 10, 1,089. If that's wrong, somebody tell me. And then what do you divide by? You're right, we're going to take 1,089 and divide.
By 30, which is 5, 11, 12, and 2.
Yeah, you
Got
add
it.
the frequencies up.
Yep. And I actually even set it up here if you wanted to look there. 30 dishwashing detergents. So divide by 30, which is the total of frequencies if I don't actually give it to you. And that comes out to be,
272.3.
okay, and that would be your average. And remember, we're trying to find an average. So it should be somewhere within these class limits, right? 36.3 would be just before 37. So that seems about right. It's almost right in the middle, and this is fairly symmetric. So that seems to be to make a lot of sense. If it wasn't symmetric, you know, if it was heavy on the bottom, it would pull down the average. If it was heavy on the top, it'd pull up the average. Remember, if it's skewed left, that pulls the mean down, and if it's skewed right, that pulls the mean up.
So you add the frequencies and divide the, yeah, okay, I did it wrong. I divided by 4.
That's a really common mistake. Yeah, you don't want to divide by 4. You want to divide by how many total, in this case, how many detergents did you? And think of this as if you actually listed this out. If you listed this out, we're assuming there's 5 24s. So 24, 24, 24, 24, 24. And we're assuming there's 11 33s, 33, 33, 33. If I just kept doing that, there's 30 values that I would be listing out. So I want to divide by that, not the number of classes. And again, if you want to practice on this, this is out of, I want to say it's 3.3. Don't quote me on that, just a second. That's variation. No, actually, I think it's 3.1 because it's a mean. Yeah, so this is out of 3.1 if you want to go back and practice some of these. You can go back to the book, you know, pull some out of the exercises in 3.1, or you could go to the practice problems and look for some in the practice problems in Connect Math. I kind of like to go to the ebook like we did. Remember the other day when we did that, when we just went to the ebook and looked at the review at the end of the chapter or the problems at the end of the section, and then you can just, you know, check them at the back. You can find the problems you want quicker than when you go to Connect Math and try to hunt through the problems. It takes a little bit of time to find the problems you want when you do that. All right, let's clear this up. Now this one, people want to go a little too far because we've done further than this, but all this question asks is to find the z-score. Now I know there's lots of problems where we find the z-score is like the first step of several other things to do, but this one literally is just a 3-point problem that asks you to find the z-score, because that's all the further we went in chapter 3. So do you guys remember how to find the z-score?
You subtract the mean from the value and divide by the standard deviation.
Okay, so you take your, you know what, I think on the key I wrote x bar instead of x. It's supposed to just be x. So x minus mu over sigma, right? So in this case, what's the x?
1850.
Yep, that's the specific bison that we're looking at is 1850. And the average of the bisons is 1500. So what that means is that bison, that particular bison, is 350 pounds above the typical bison, or the average bison. And the standard deviation is 290. So 350 divided by 290.
1.21.
0.21. And for z-scores, we almost always go 2 decimal spots because that's what's in the table. So, I mean, you could say it's 1.207, but when you go to look, if you were to look it up on the z-chart, you can't find that anyway. You can only find it 2 decimals. So, and that's it. On this one, you're done at that point. You don't have to go to the chart or anything like that. It only asks to find the z-score. So you're done. You don't have to go look that up. That's in chapter 6 that we did that. That one you should feel pretty comfortable on, because we do that a ton of times in 6 and 7 and 8. We do z-scores over and over and over again. So, all right. Oh, and when you're doing the exam, this formula is not in chapter 3. We did it in chapter 3, but they list it in chapter 6. So this is in chapter 6, is where the formula is. I'm not sure why they didn't list it in chapter 3. I mean, shoot, in chapter, what is it, chapter 5, they list, here, let me pull it up. It's kind of funny, because in chapter, you could say, oh, well, they don't want to be redundant. You know, so it's right here. But here they put the expectation formula and the mean formula both in the same chapter, and they're the exact same formula. You know, if they were trying to save space or not be redundant, they could have put those together, but they didn't. So I'm not sure why they don't list that over here with chapter 3, but they don't. All right, so let's go back to, so far, how do you feel about the final? Is this making you feel better or worse?
Better.
Better? Feeling pretty comfortable with all this stuff? I mean, I can't ask you 500 questions on the final, right?
No, please
So,
don't.
yeah, no, it's like, it's right about this. I want to say the final has, I don't think it's exactly the same as the review, but it's right around this, somewhere between 25 and 30 questions.
So, the regression line, I think that's what it is. The R,
Uh-huh.
is it the same as we did on the first test, or do we actually have to?
No, it's the same as the first test. You want to do that one after? Let's do this next bit, and then we'll go do the regression line one.
Okay.
Because we did that actually with the first test. So on the first test, we did it after chapter 3.
Yes.
So let's do chapter 4, and then we'll go back. Then we'll go do the regression line, and then come back to 5. Okay. So on this, it says that we have a gumball machine. It has 60 grape, 40 cherry, and 50 lemon gumballs. And we want to know the probability of getting, and I would recommend writing something like this as soon as you see it so you don't have to keep remembering it. What's the probability of grape, cherry, lemon? So you get a grape, then you get a cherry, then you get a lemon. And you don't put gumballs back in the gumball machine, so they're not replaced. So what do I do with that?
So you would do 60 over 50 times 40 over 149?
Yep, so the total, if you add these all up, 60 and 40 and 50 is 150.
Yes.
So 60 out of 150, that's the probability that you're going to get a grape, right? Now, why 40 out of, why did we change this bottom number to 149?
Because you took a gumball out, so it's one less gumball in there.
Yeah,
Not replaced.
not replaced. We had 150 gumballs, but when we took that grape one out, now we've only got a total of 149 gumballs. Okay, so you got to adjust that. And then the last one is lemon. That makes our total now is only 148. And the number of lemon ones is still 50 because I haven't taken any lemons out. And that's it. You just multiply those out. With these kind of big-ish fractions, it's probably not going to come out a super nice fraction. I believe on the test, I just wrote it as a decimal. So however you want to compute it on your calculator, but then the final answer will be a decimal. So give that a shot. See if you can get it typed into your calculator right.
I got 0.0036 and some other numbers, but I think I did it wrong.
That's what I got too.
There you go.
Yeah, that's what I got.
You didn't do it wrong then, probably. 0.362778889. Is that what you guys got? All right. You didn't do it wrong, Brittany. You have it right. So 0.036 approximately, because it's 0.362 or 3.6%. So you only have a 3.6% chance, less than 4 in 100 chance that you're going to get grape, cherry, lemon. Now I did on the key, I did this too. I can't remember exactly what I put on the key, but I put like a bonus question with one where you repeat. So what would be the probability that you got, can't remember what I put on the, anyway, the one on the key is different than this, I'm certain. I'm not going to remember it the same, but let's say I had grape, cherry, grape. So instead of grape, cherry, lemon, I have grape, cherry, grape. Well, the first one would still be 60 out of 150, right? But what about the next one?
40
Well,
out of 149.
that would still be 40 out of 149 because I still have 40 cherry gumballs because I haven't taken any out, but I have one less gumball.
Would the next one be 59 over 148?
There you go. Because I already took out a grape, right? So I don't have 60 grape gumballs left in there anymore. I only have 59. So I have to lower that top number and the bottom number. So if it repeats one, make sure you take into account that one already got taken out. You know, and this could be gumballs, it could be cards. If I do cards, I will absolutely put a sample set of the card, or not the sample set, the I can't remember the name of it. Anyway, I'll put the card deck, a picture of the card deck on there. And I don't know what this equals, but it would be a little bit, it'd be a little bit better.
4.1%.
What is it? 0.043?
Yes.
Okay. And that's because these first two are the same, but this last one, 59 out of 148, is a bigger number, so you get a little bit bigger percent. Sample space. That's what I was trying to come up with. Not sample set, sample space. So if I ask you about the cards, I'll give you a picture of the sample space of the cards. All right. What about this next one? And I didn't put this on the key, but I'm going to show you, I could ask you either of these two questions. So the one that's on the review is an apartment is assigned at random. What's the probability that it's the second floor or has 3 bedrooms?
Okay, so first, would you add them all up? Like, so it would be 2 plus 2 plus 2 and then the 1, 1, since it's the whole second floor and 3 bedroom?
Okay. How come not 2 plus 2 plus 2 plus 1 plus 2 plus 1?
You don't want to repeat it, right?
Right. We've already counted that the second floor 3 bedroom, right? We've already counted that one, so we don't want to count it again. So you're going to do just like you said, 2, 2, 2, and then 1 and 1. I don't need the 2 because I already had it. So 2. Ooh, my pen is being weird. Okay, 2 plus 2 plus 2 plus 1 plus 1 out of
The whole entire thing, right?
yeah, which is, let's see, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I think it's 17. Is that what you guys got?
Mm-hmm.
So 8/17.
Which is 0.47.
47. Go one more decimal spot. Because with percentages, we tend to go to 3 decimal spots. So 471. Yeah. So about 47.1%. So the other thing I could ask would be something like, what's the probability that it's a 2-bedroom given that it's on the 3rd floor?
Only count the 3rd floor.
It'd be
Right.
4 to 6.
Okay, so only count the 3rd floors, you said, which is correct. So only count the 3rd floors. Don't do any of these. So you said 4 out of 6. That's correct. So there's a 6 total here. There's 6 3rd floors. We only look at the 3rd floors because this is the given. So that's your bottom number. And then the top is what you want. So 4. So 2 6 or 2/3 or 4 6 or 2/3 or 66.7%. So I could ask a given also. It'll either be an or a given. I won't ask both, just again, I can only ask you so many questions. I can't give you 100 questions on the final. So I've got to limit things. And so I'll ask you one of those two types of questions out of the two-way tables, either a given or an or. Okay, but you guys did great on that. Okay, so if two events cannot occur at the same time, is that the definition of mutually exclusive?
True.
Yes.
Yes. So I don't know, some things that would be mutually exclusive. You know, can you live in Dallas and live in I don't know, LA? Are those or here, we'll even do something that's not quite so obvious. Could you live in Dallas and live in California? No, because Dallas is in Texas. There's no way that you could live in Dallas and live in California. I mean, don't get into the whole two houses thing, but if you have one residence, there's no way you can live in Dallas and live in California. They're mutually exclusive. You either live in California or you live in Dallas, because Dallas is not in California. And California does not include Dallas. So those are mutually exclusive events. Two things that cannot happen at the same time. What about having a, I don't know, some cool car, having a Ferrari and having a red car? Are those mutually exclusive?
No.
Yeah, so these are mutually exclusive. This is not mutually exclusive, because you could have a red Ferrari, right? So those are not mutually exclusive events. So mutually exclusive means they can't occur at the same time. The other thing that we talked about in chapter 5, besides mutually exclusive, was independent. So independent and dependent. Independent means that they affect each other. And then dependent means that they don't affect each other. So independent events would be like roll a die, flip a coin. Are those are independent events, because the coin doesn't care what happened to the die, right? They don't affect each other. So what would be
Would it be switched? I'm sorry.
Go ahead.
Would independent be like they don't affect each other, and dependent is they do affect each other?
Oh,
'Cause the way
geez.
you wrote it,
Yes,
I'm-
thank you.
Okay.
I just noticed that too.
Thank you. That would have really confused somebody. So independent, yeah, I have those mixed up here. Let me just switch this around. That would be the easiest. Independent means they don't affect each other. Dependent means they do. So let's get rid of this example too, because that's not the right example. Okay, so let's put that down with this other one. Okay, so independent means they don't affect each other. So that would be like flip a coin and roll a die. Phew, thank you for fixing that. So the die does not care what the coin did. They're independent of each other. They aren't dependent on what the other one does. So whether or not you flip a head or a tail doesn't change the outcomes or the probabilities of rolling a certain number on the die. You guys okay with that? Okay, so what's a example of dependent?
Pulling a card out of the deck and not replacing it, would that be one?
Mm-hmm. So a card, then another card without replacement. So if you don't put it back, I mean, that's exactly what we did up there with the gumballs. When I took out a grape gumball, that affected the next probability because there was one less gumball. If I drop that gumball back in and you know, rearrange the, you know, could somehow shake up the gumball machine and make them all random again, then it would not, it would be independent, but that's not what we typically do with gumball. The gumball machine is kind of funny actually, because if you got real technical about it, a gumball machine is not 100% random, because when you put your money in, the gumball's already dropped into the slot. So you really don't, it's like the cat, like Schlesinger's cat, or Schrodinger's cat. Like you don't know, but you do know. Like it's decided what's going to drop. You just don't know what it is. So anyway, does anybody have any questions on the dependent, independent? So independent just means they don't affect each other, and dependent means they do. And mutually exclusive, if you get confused, think of that like a relationship. It means if you're in a mutually exclusive relationship, it means you don't have two relationships going on at the same time. It's two things aren't happening at the same time. You're not dating one person and dating another person. You're mutually exclusive. What do you guys think? Okay with those?
Yes.
Now this one is what type of problem? What is the number of different ways 4 signal flags can be run up a pole if there's 15 to choose from? Just in general, what type of problem is that?
Is it a permutation or a combination?
Yep, it's a P or C problem, right? Because you have a total that you're selecting from, and then a total number that you're selecting. So you're selecting 4 out of 15. So now the question is, does order matter or does order not matter?
Wouldn't order matter because they're signal flags?
Yep. And so when you're doing signal flags, when they used to do this that's a really bad poll. When they used to do this for signal flags, I think they still do actually for boating. When you put the signal flags, the order matters. So if you have one that looks like this, and one that has a dot on it, and another one that has an X, and another one that has stripes, each of those means something. And if you put these same 4 flags up, but in a different order, that would mean something different. And if anybody knows anything about signal flags, and I just did something really crazy, just let it go, because I don't know anything about them, other than the order does matter. So what do you guys think on this one? Do I do a P or a C since order matters?
Combination?
C.
P.
P. Order matters is P.
Oh.
So Brittany, I always remember that combination locks are named entirely wrong, because combination locks, the order matters, but truly combinations, the order doesn't matter. So combination locks are completely wrong. It's permutation. They can't even be called permutation locks, because you can repeat numbers. So it can't really even be either of them, but it's closer to a permutation because the order matters. Okay, so what's my first number on my permutation?
15.
Okay, so my first number is 15. P4. And then all you have to do at that point is just put it on your calculator. Don't worry about doing it by hand. So 15 P4. You could also do 15 times 14 times 13 times 12 if you wanted. So are you guys getting 32,000? Like that?
Yes, that's what I got.
So there's a lot of ways. If you can put 4 flags up, there's a lot of different signals you could send on that. There's technically 32,760 different signals you could send up that pole with just having 15 flags. That's a lot. And so
I have a question.
Go ahead.
On something that order doesn't matter, why is the outcome smaller than an outcome when order does matter?
Okay, so I just erased it, but when order doesn't matter, I could put those 4 flags in any order and I'd get the same thing. So there's less ways to do it. Let's do something really simple. So like, let's say you have, I don't know, A, B, and C. If order matters, A, and you're picking 2, AB would be different than BA. So it gets you two things, right?
Mhm.
But if order doesn't matter, these are the same, and that's just one thing. So when the order doesn't matter, it gives you less options or less things that are different. So if I do ABC, if I do say I do a 3P2, then I could have AB, BA, AC, CA, BC, and CB. So there's 6 different ways, right?
Mhm.
But if I'm doing a combination of a 3C2, then an AB and a BA are the same. So I have A with B, A with C, and B with C. There's only 3 different ways to do it.
Okay, I got you.
Because
Without
AB and
repeating. I got you now.
because an AB and a BA are the same thing. So this would be like, I don't know, think of this as a very small class going and filling a very small, representative committee or something. In this case, you're saying you have a president and a vice president, and so AB is different than BA, where in this case, you're just picking 2 people to go represent. So if you pick A and B, it's the same as if you pick B and A. So the C's are always smaller than the P's. In fact, they are incredibly smaller when the numbers get big. When these numbers get bigger, the C and the P will be really different. What do you guys think? I think I promised that we go do 10 next. Let's do 10, and then I think we'll call it a day and pick up with 5 on Wednesday. And we'll probably get done. That probably won't take us the whole time. So on Wednesday, after we get done with 5, 6, 7, 8, we'll probably go do maybe a few other problems too. I'll pick some different ones. Okay, so
when's
Isaac, this is
I'm sorry. When's the final?
the finals due Friday. Yeah, sorry, it's not Sunday. Don't get the, we've always had things due on Sundays, but Friday's the last day of the semester. I have to have grades in on Monday. So in order to be able to have time to go through and replace like your chapter grades with your final grade and all of that. So when you guys see your total grade after you take the final, if your final grade is better than one of your chapter grades, that's going to go up. So I'll have to go in and replace those.
I'm sorry,
Okay.
What time on Friday?
Midnight.
Okay, thank you.
Yeah. I mean, I could have done it earlier, but I didn't really see any point. I'm probably not going to work on it Friday afternoon anyway, so why would I make you guys get it done sooner? Try not to leave it till the last minute, though, in case you have any problems. Okay, so I'm talking to the wrong people. The people that are going to do that are probably not here right now. Okay, so we have an R of negative 0.71. Let's talk about that first. Comment on the R. That R is strong or weak?
A strong negative?
Yeah, I would say it's fairly strong. It's not super strong. Really strong would be like like an 89, 90, whatever. But it's fairly strong. It's not horrible. And then it's negative. So I would say this is kind of in the middle. On the test, I tend to do one that's a little bit more distinct. So it will be like a negative 0.4 or a 0.98. Really strong or really weak.
So why is it fairly strong again?
Because perfect is -1 or 1.
Yes.
And then the closer you get to 0, the worse it is. So this is
Okay.
no correlation. And then this is perfect. And this is perfect. And we're about here. So it's not perfect, but it's definitely not super close to 0.
So it'll be 1 if it was like maybe 99, then you round it up to a 1.
Yeah, 1 would be like perfect. Like it fell
I
in
mean,
an exact
yeah.
straight line. Whoops, I wrote that wrong. What was your question? I'm sorry.
I meant like if it was negative 0.99 instead of 0.71,
Hmm.
it would be -1 because you rounded up the 9 to make it a 10 to make it a 1.
Right, but even if you wouldn't round it up, you would just say this was nearly perfect. Like you
Okay.
wouldn't round it. You'd just leave it at 0.99. So you'd say it's near perfect negative. It's not perfect, but it's near perfect. So it's strong. So this one would be a very strong negative. Not perfect, but very strong. A very strong positive, maybe you get a 0.93. That would be a strong positive correlation. What does a negative positive mean? Like, what does that do on the graph? Like, since this R is negative, what does that do to the points on the graph?
It's gonna go down from left to right. If that makes
Yeah,
sense.
the points are going to go, as the X's get bigger, the Y's are going to get smaller. That's all that means. It's like a reverse correlation. So when I graph this, what do I want to make sure that I'm doing on the graph? Like this down here, what am I supposed to do with the labels on
It's a
the
scatter. It's a
x-axis?
scatter plot, right?
Yep. So what
So
Do
should
the
go
labels
down?
go from greater to least, or no?
It's just
They go from least to greatest. And what goes down here? Is this the production or the birth rate that goes on the bottom?
Production.
Production.
birth rate.
No, this is like
so
the
this
X.
production is X and then birth rate is Y.
Yep, so this would be birth rate. Sorry, writing down is kind of weird on here. Okay, so birth rate is over here, and then production is down here. Because this is the X and this is the Y. What's the other thing that you need to do? When I go to put these points on here, what do I have to do first?
Would you make good points? I think.
Good, not necessarily good points, but good. I got to label these, right?
Yes.
I can't just say, oh, this is 800, this is 3100, this is 9600. I've got to label these with even spacing before I put points on it. So what do I have to get up to?
If it's 40,000,
I have to get up to 40,000.
I guess you would do by maybe 500.
I got to get all the way up to 40,000.
But that is true.
That'd be
Or
80.
5,000?
By 5,000s? I think on the key, I actually went by 8,000s.
8,000? Oh, okay.
Because I mean, you could do 10s. That would be fine. You could do 10, 20, 30, 40.
Well, there's 1, 2,
5,
3,
10,
4, 5, 6,
20.
7. So 8,000 will work to get to 40,000 because 8 times 5 is 40.
And you could go by 10s or by 5s, but you'd have to
But that
add
would
a
take
couple
longer.
things. Yeah, it'd be 5, 10, 15, 20, 25, 30, 35, 40 would be over here, which you could do. That's fine.
So we can add on if we want to.
Yeah, but remember that it's going to be drawn for you. You're just going to have to pick the right one.
Yes.
So you really just have to look and see which one is appropriate.
Mm-hmm.
So, okay, so there's 40,000. And the key is you want to make sure that you're going by even amounts along the bottom and that you have production at the bottom. The first one should be down here. All right, what about the next one? What about over here?
Birth rate. So the highest is 5.7. So I guess maybe just going by one.
See,
Yeah, would you go by solid numbers or the decimal?
No, you just want to label this evenly. So I would just go 1, 2, 3, 4, 5, 6.
I
And then when you graph
feel
5.
like decimals would make it more difficult.
Yeah, and if you went by like 0.5s, it would, 0.5, 1, 1.52, 2.53,
Yeah, 'cause
you'd
that
run
would-
out of room. Okay, so now we just have to graph it. Where would 800 5.7 be?
At the
Closer to 0, right?
Very
Oh, yeah.
close to 0 and way up here, right?
Yes.
It's only 800. It's not even 1,000. So it's pretty close to the y-axis all the way up here. What about 3,100?
Like almost halfway.
Yeah, not quite, but almost halfway. 2.85. So about here maybe. And then you just keep going. So
The
9,600
thing
would
is,
be,
the points, if I remember correctly, the points don't hit the line, right?
Yeah.
They just go on either side of it.
I don't think, yeah, none of these fall right on 1, 2, 3, 4, or 5, and none of these fall right on these numbers. Yeah, so they're all kind of in between. So 9,600, 2.5, 25,000 would be just past 24,000, 1.57, so just a little bit past 1.5. Oh, 40,000 does fall right on it. So 40,000, 1.78 would be like here. But can you see that they're trending downward?
Yes.
I mean, if we graphed this equation on top of these points, it would look something like that.
So for 29, what you do is you input one of the points on the x-axis and times it by the 0.0005 plus
Well,
add 4.
This one, I actually don't ask you to put again, it's pretty hard to do on an online test. So I actually don't even ask you to place the linear equation. I just ask you to use it to predict the birth rate and say whether it's good or not. So there's one step that's left off from what we did before. You don't have to put the line on there. But that's what you would do if you wanted to put the line on there. You'd pick a couple points and then plot them. So what would
Let's
that
see
be? If
if
I
they
put a
line up
0
with
in,
the,
you'd get a 4. And if you put I don't know, if you put 40,000 in, what do you get? If you wanted to do that,
if I wanted to put 40,000.
0.0005. Something's wrong. Negative
I got 2.
0.00005 times 40.
Yeah, I got -2.
Yeah, plus 4 gives you 2. So this would be the actual regression line if you were to put it on here. But it doesn't ask you to do that. Okay, so it asks you predict the birth rate if the production per person is 16,000. So what do I do with that 16,000?
You put that as the x.
Okay, so I do, sorry, I'm not going to move this because otherwise it'll mess up our graph. So I'll put it over here. So it'd be,
I got 3.2.
0.00005 times 16,000 plus 4. And you said you got what?
3.2.
3.2. So we're saying that if the per person production is 16,000, then the average birth rate per each woman is about 3.2 children.
It kind of hits the middle of it, of the line.
It'd be right here, right?
Yes.
So do we think that's a good, useful prediction?
I want to say yes because it hits the line.
Well, whatever we pick will hit the line because we're plugging it into the formula.
Well, true.
So what do we
it's
think?
in between 2 points and not on the outside of them.
Doesn't it have to do with our R in the beginning?
It has to do with the R, but it also has to do with what he's saying about it being between. So is the fact that 16,000 is between our other values, is that good or bad?
That's actually good, right? Because it's a relative.
Yes.
It's called interpolation. So it's interpolation because it's between the given values, which is good.
I thought we said the last time we did this on like the review, you said it would be bad if it was like outside the 2 markers.
So I don't want to go below 800. Like I wouldn't want to try to predict, if the yearly production per person was 65,000, I wouldn't want to use that. That's extrapolation. No. So that's definitely bad. So this isn't too bad. It's somewhere between yes and no. Interpolation is good. So that's good. but the R isn't super strong. So this one, again, it's a little wishy-washy because the R isn't very strong. So it's interpolation, which is good, but the R is not real strong. So it's a worthwhile,
So
but
is
it's not
this,
it's not wonderful.
so is it going to be the one that's that we have to write down ourselves, or is this like one of the multiple choice ones? Like
It's going to be a
on the
multiple
previous.
choice. It's going to say something like, it is good. Like this one, if I had put multiple choice, I would say no, because again, this one, the R is kind of wishy-washy. It's sort of in between good and bad, but I'll do one that's like really good or really bad. So let's say the R was strong, but I did extrapolation. You'd have to say no, because even though the R is strong, the value that we're predicting is extrapolation.
So is it going to look like the hypothesis testing test? Because that was so confusing. I was writing the stuff down, getting my thoughts together, but I had to make sure I picked the right one because there were similar ones, but there were subtle differences.
Right.
And so,
and that's why I said on those to do your hypothesis test and then look for the right one, because otherwise it's easy to get fooled. So on this one, again, let's say the R was negative 0.54 instead of negative 0.71. Let's say it was bad. So you would say, no, this isn't good or useful. It's, 16,000 is interpolation, but the R is weak. That would be the answer that you're looking for. You'd be looking for the one that says the 16,000 is interpolation, but the R is weak. So no.
What was the one you said not to use? The words. Why?
I'm not sure.
It was something like if it was below 5 or something like that, you weren't supposed to use, I guess.
Like on the test, it's either going to be weak or strong. Like I'm going to give one that's either weak or strong. So it's either going to be like this, horrible, that's terribly weak,
Okay.
or it's going to be something like, negative 0.92, which is definitely strong. So it's not good. This one's kind of wishy-washy because it's kind of strong, but it's not really strong. So, but it's your choices are either going to be strong or weak.
Okay.
So in this case, you would say no, 16,000 interpolation, but the R is weak, so it doesn't predict it very well. So that's what you would be looking for out of your selections.
Okay.
And then the other ones would probably say something like, yes, I used the equation, so everything is dandy. Or no, it's interpolation and the R is, or it's extrapolation and the R is weak, or, there'd be all the different, like one of the ones that would be wrong would be if it said 16,000 is extrapolation, even though the R is strong. Well, is that true in this case? Was the 16,000 extrapolation? No. And the R wasn't strong. So this is the wrong. I mean, the no's correct, but the explanation's wrong. It's not no because the 16,000 is extrapolation. It's no because the R is weak, even though this is extrapolation, or interpolation rather. So they're looking for that one that has the descriptions right. So, and it could be yes. If it's interpolation and a strong R, then one of the choices would be yes, because R is strong and it's interpolation. So.
Professor, on the test, is there going to be any problems relating to correlation coefficient?
That's this R right here.
Oh, okay.
You don't have to compute it. You just have to talk about it.
Okay.
So for the test, we can take it between now and Friday, right?
Yep. Anytime between now and Friday at midnight.
Okay.
And it just uses Respondus, just like your last two tests.
Okay.
So I think everybody's worked out your issues with that, and
Yeah, I solved my issue.
so everybody's got that figured out, and hopefully that won't be stressful like it was on the first test. That was stressful for a few people on the first test, but
I still haven't figured out how to do the test corrections.
oh, if you go back to your test
Yes.
and you click on the test, and then off to the side it'll have a little arrow, and it'll let you look at your submissions.
Okay.
So I'm done with problems for today. I'm going to go show Isaiah where that's at. Does anybody have any other questions you want to ask? Okay. So let me
I had one. I'm sorry.
go ahead.
It was on that problem we were just at. How do you tell the difference if it was oh shoot. You erased it.
Go ahead. Just ask it, and I'll put it up here.
I'm trying to think. I can't remember the words that you were using.
Was it for chapter 10?
Interpolation.
Yes.
Interpolation?
Yeah, or the other one. How do you know the difference between the two?
So interpolation is where they pick something to predict that's between the original values. So like that 16,000 was between the 800 and the 40,000. Like it was within that same range, which is fine. That's where you can use a prediction. But if they go above that or below that, so like if they had asked you to predict something for like 65,000, that would be extrapolation because you went beyond the original values that were given. And that's dangerous. That little red line segment that I drew, that's only valid for that little area. Like you can't just keep going on forever and assume that, oh, this is going to keep acting like this forever. At some point, it's going to change or may change. We just don't know. So interpolation if it's in between the x's that were given, and extrapolation is if it goes below or above what was originally given.
Okay, got you.
So in that case, if it went below 800, which you can't really do much below 800, but and then or above 40,000.
Okay.
So here's where you find the
Test corrections.
yeah, and it's kind of weird because I have to go to a student view to show you this, and I don't have any submissions because I'm not a student. So it's a little weird, but I'll show you where it's at anyway. So if I go to view this as a student, this is more like what you guys see. And you go to content, and you go to your exam. Oh, that's the corrections. So if you go to your exam for say 7 and 8, and right here, see this little arrow?
Yes.
And view submissions.
Okay.
And then it'll let you go back and look at what you missed, and you can do test corrections.
So I remember someone saying it takes you back to Respondus to look at it.
It might. Does it really? I wish I could take that off. If it does that, I apologize.
It takes you right back, and then it has you make sure all your Skype and everything is closed before you can
review your answers.
They probably don't want you to do like clips of the test and stuff.
Yeah,
like that.
I understand that. I was just asking.
So, and then once you get it done, then you just I don't know, do cam scanner or take pictures of it or whatever and put it in this Dropbox.
Okay.
So the Dropbox just, you take your pictures or your PDF and you just upload them here.
Test corrections are the same as we did for the first one, right?
Mm-hmm. And I do have it listed out here. So explain your mistake, work it out correctly, and write and work a similar problem. And if you do that, you get 5 points back.
Thank you.
No problem.
What I did for my corrections, it was really easy. I just went to Respondus and then I wrote down every question and then the answers, so that way I didn't have to keep constantly opening it up and going back and forth because it was a pain.
So you just wrote them out and then I
just completely went away from the exam and just worked them out like they were regular like homework problems.
Yeah, that would probably be easier. The only thing that it might not be is, like Isaiah was saying, is um, the hypothesis testing. But I guess you could do it and then go
I
back
mean,
to the
all I
test
gotta
and
do
pick
is
which
work
one it
out the
was.
problem
Right.
and show how I got the correct answer, and then find a similar problem, which you said we can just find from anywhere. It doesn't
Right.
have to be specific. We can find it in the book, from our notes, etc.
Yeah, you could even change the problem. Like you could make it a Z instead of a T, or you could change the alpha or something like that. Just anything that makes it a little different so you have to rework it. Or you could just take it off of a notes or homework problem or anything like that. All right. Anybody have any questions before we call it a day? All right. Enjoy the nice weather. It's pretty out today. So you're like, thanks a lot. You give us math to study and then tell us to go enjoy the nice weather. I have to
It's
stay
all
in
right.
and do.
I ain't got nothing to study while I'm at work. I'll be too busy.
Where do you work at?
A nursing home.
Ooh, that's kind of a bad place to work right now. Has anybody gotten sick?
No, I mean, I got tested for free, so I ain't complaining. So
That's not bad. And all your residents have been good?
Yep.
Good. So are they keeping everybody out still though?
Yeah.
It's funny because you know, you see pictures of like people coming to the windows to say hi to their grandmas and grandpas and things like that. And it made me remember this story that my grandma told me that I thought was just crazy at the time, but they thought my uncle had polio when he was little. And so he got put in quarantine. And she told me about how they used to go to the hospital after work and stand outside and wave at him up in, like he could come to the window and wave to him, but they couldn't go up and see him. And at the time when she told me that, I thought that's just the craziest thing I've ever heard of. And then
that's
I
all.
realized that's just exactly what we're doing right now.
Yeah, that's all we can allow. Like, we can take them to the door or the window and have them talk to each other through the door or window, but they're not allowed to come in unless it's like an actual emergency for that family member.
Man, that's and it's like I said, it's like repeated history. So anyway, I'm gonna let everybody go. We'll see you on Wednesday for our last review session. We'll definitely finish up the review, and then if we can, we'll do some other problems of
All right.
whatever you
Thank
guys
you.
ask. So bye everybody. We'll see you on Wednesday.